Hi there, students. It's Mr. Krause. Seems like my camera's off a little bit. That better? I think that's better. All right. So anyway, hi kids. Wow. It's great to see you. I feel like I haven't seen you in a while. Oh my God. Yeah, shut up. Man, you're making me mad, kids. I don't know why. Because I'm a little crazy. It just seems like that's off still. Is it off? I just keep going back. I don't know. We'll see. Just seems like it keeps getting moving over there. I don't know. Hopefully that works. Okay. By the way, my name's Mr. Key. I'm here to help ye. That's pretty funny. Not even close. Not even close. You guys ready? All right. We're gonna rock and roll and rock. Let's see how fast I can go through these. I'm gonna like zoom in so you guys can really see what I'm doing here. Like zoom in like craziness. Holy mackerel, that's just ridiculous. All right, so here we go. Quickly. How fast can I get through these? All right. If a problem's in log form, is that thing moving again? Sorry, kids. I feel like I've got a ghost in here moving my stuff. All right, we're in good shape. Whatever. All right, if we have something in log form, what we want to do is turn it into exponential form. So it's log. I turn it into exponential form. It's all about that bass. When I sing, it's all about that bass by whoever that singer is, and I love that song. I drink my brewer's coffee. Stopped off on the way home. Had to go to the doctor's. All right, so it's all about that base. So we're going to write the base. And then the other things that go along with it get switched. 4 squared equals x. I think you all know that x equals 16. Done. All about that base. Got a log. We turn it into exponential form. All about that base. These switch. Guys, you have to get really comfortable with this. 2 to the 4th equals 5x. Divide by 5. Divide by 5. Now, 2 to the 4th is really 16. So in this case, x is equal to 16 over 5. Wow. Don't you wish they were all that easy? You're like, man, if they were all that easy, I can do that. All right, here we go. It's all about that base, So in this case, my base is 10. Even though I don't write it there, it's sitting right there. It's kind of like a little lead. There it is right there. Just can't see it. So 10 to the 1 is equal to x plus 6, right? 10 to that exponent, and you switch. So 10 to the 1 is just 10. So I'll subtract 6, and I get x equals 4. Man, Mr. Krause, I can even pass that test. All righty, we'll see. All right, the base, all about that base. 3, switch. 3 squared equals 3x minus 1. 3 squared is 9, so I'm going to add 1 to it, and I get 10 equals 3x. Divide by 3, or x equals 10 thirds. What did I just write there? 10 over 3. Man, we are rolling and rocking. All right, so here's another one. Here's a different kind of problem. So now you got to be able to go back and forth. This time I have a log equal to a log. Notice these logs are the same. So, for example, if I wrote here in very nice black letters, log base 4 of something, you would say, oh, that's equal to log base 4 of the exact same thing. So long as these two things are the exact same thing, these have to be equal. So these two things have to be exactly the same, otherwise known as x plus 2 equals 8, or x equals 6. Not bad. Over here, 2 logs, as long as those bases are the same, I get this, and this. So I get 2x plus 3 equals 3. Subtract 3, I get 2x equals goose egg, or x equals goose egg. And that kind of makes sense, right? If this went away, when I just have log 3 equals log 3? Oh, yeah, that's right, Mr. Ground. I didn't even notice that. I probably should have. Don't worry, I didn't notice it the first time I did the problem either. All right, so before I can do this problem, let me get back to my red. I have to return the exponent. So let me put that 1/2 back there. Now, you all have to remember what 1/2 as an exponent is. But, again, I have a log equal to a log. Oops, I got to return this exponent too. So what I end up with is x to the 1/2 power is equal to 4. Well, maybe you don't like 1/2 power. Maybe you would like what it really means, and that is square root. So the square root of x is equal to 4. Well, if the square root of x is equal to 4, I square this side, and I square this side, and I get x equals 16. Ka-chang! Let's return this x, or return this -2. So I get x to the -2 is equal to 9. Well, x to the -2 is really 1 over x squared. You have to remember that. I'm not going to teach you that. When I remind students of something they should know, and it frustrates me, I drink Brugger's coffee. It calms my nerves so I don't beat the sense out of anybody. I wouldn't beat any of you. You all are awesome. Well, except maybe you. So anyway, let's cross multiply. 9x squared equals 1. Divide by 9, I get x squared is equal to 1 over 9. Now, at this point, what I would do is just take the square root. When you take the square root, you got to remember to put a plus or minus, so you get x is equal to plus or minus 1/3. Now, I keep forgetting to do this, but you are supposed to check all logarithmic solutions. And 1/3, because if I put in -1/3 right here, I would have a problem, because I can't take the log of -1/3. So my solutions for this one is 1/3. Not -1/3, just positive 1/3. All right, kids, going off to 9. I'm on 9 already. I feel like I'm like a third of the way through almost. But I'm not even close. All right, let's return the exponent, 3. All right, so this is a different kind of problem. Now we're on another type of problem. Oh my God, this is so much fun. Oh! Yeah, whatever. Anyway, we've got 2 logs. Let me highlight them because some of you don't see them. There's a log, and there's a log. Now, that's not 2 logs equal to each other. That's easy. We just did that. We got 2 logs that are being added that have to come up to be 5. Well, okay, we can't deal with 2 logs. What we want to do is we want to condense them to 1 log. Don't forget, when you condense, you still have a log. You just have 1 log. And when I have adding, it turns into multiplication. So this turns out to be 4 times x minus 1 cubed equals 5. So the first step, return the exponents. That goes back. Then what we want to do is we want to condense them. We condense them. And now it's all about, I'm tired of black. It's all about that base. Got a blue. So it's all about that base. So there's the base. 2. These 2 are going to switch. Chink, chink, chink. 2 to the 5th is equal to x minus 1 cubed. Okay. Oh, I forgot about the 4. 4. All right. So let me erase this because it's kind of in my way. And let me get my black back out because I need it. I thought I had purple, but I don't know what happened to it. So anyway, 2 to the 5th is really 32. So I'm trying to save myself a little bit of writing here because I'm probably running out of room. So I'll divide by 4. I divide by 4. These cancel. So I get 8 equals x minus 1 cubed. Well, then you have to ask yourself, because I don't really want to cube all this stuff out and then that'd be a pain in the neck. Yes, it would. So I want to use my brain. My brain says that if this thing in here is a 2, 2 cubed is 8, correct? That's what my brain says. So what I'm thinking is, what am I going to put in here for x to make this thing equal to 2? And that would be x equals 3. Because 3 minus 1 is 2. 2 cubed is 8. Done. Yes, you should check them. All right, we got to return the exponent. Squared goes there. A different kind of problem now. Now we have subtraction. Now we still have to condense. We still want to get down to 1 logarithm, so log base 3. But in this case, it's x plus 4 over 9 equals 2. All right. So now it's all about that base. Ooh, yeah. So I'm going to copy down that base. 3. These two things are going to switch sides. So 3 squared is equal to x plus 4 over 9. Oh, wait. I forgot to... didn't I return the exponent? I returned the exponent and then forgot about it. Oh, my goodness. I almost made a crazy mistake. All right. Well, on the right side, on the left side here, I said right, but I meant left. On the left side over here, this is really just 9, so I can put this over 1, cross multiply. So I get... I keep forgetting about this squared. I get x plus 4 squared equals 81, because I just cross multiplied. Now I'm going to take the square root of both sides. So square root of this side, square root of this side. When you take the square root, don't forget to put a plus or minus. So I get x plus 4 equals plus or minus 9. So x plus 4 equals 9, or x equals 5. That's one of my solutions. Or x plus 4 equals negative 9, and x equals negative 13 is another one of my solutions. If you were to plug negative 13 in here, then wouldn't this thing right here be negative 9? And we can't take the log of something that's negative. So this is my only solution. X equals 5. Moving on, chillin'. Chillin'. Cheerios. I don't know why I said Cheerios. So nothing to return. We have nothing to return, no exponents, but we have 2 logs, so we're going to condense them. We're going to write them into 1 log. Now, some of you don't like the fact that that base 10's not there. Maybe what you need to do is say, oh yeah, there's really a 10 there. Don't forget about it. So log base 10 of x times x plus 15, because remember, when you condense addition, it condenses to multiplication, is equal to 2. Now, you know what I'm going to say, don't you? It's all about that base, about that base. Nobody can have that much coffee in their body, so it must be just I am high on mathematics. I am. So, all about the base. 10, these two switch, and then this goes to the right side, but, you know, I'm just going to distribute x squared plus 15x. Now, I want to set it equal to 0 because it is a quadratic, and quadratics need to be solved. They feel lonely if you don't solve them. 10 squared is 100. I hope you all realize that. All right. Factoring here is a joke, although it looks like it's not. It wouldn't have been if I left that at 10. So x and x plus 20 minus 5. Those multiply to negative 100. They certainly add up to positive 15. I get 2 answers. X equals negative 20 and x equals positive 5. Now, be careful. I would be leery of all negative answers, clearly. And if I put a negative 20 in here, crashola. If I put a negative 20 in here, crashola. But the 5 is fine. So my answer is just 5. All right. I'm going to condense. Another log base 10. I'm not going to put the 10 because it's annoying. It's all about that base. You can't see 10. 10 squared equals x squared minus 21x. Does this look familiar to the last problem? It should. Bring that 100 over. I get 0 equals x squared minus 21x plus minus 100. Factoring here is not bad, although some of you might struggle with it. X and x. What multiplies to negative 100 that adds up to negative 21? That would be negative 25 and positive 4. This gives me x equals 25 and x equals negative 4. If anything is going to fail, it's probably going to be that negative. Let's check. Yep, because I can't take the log of negative 4 because that crash is gone. So my only answer here is, in fact, 25. Oh my goodness. 12 down, 28 to go. Actually, 27 because don't forget number 14 is, in fact, a bonus. we go. All right, so we have subtraction here. So this subtraction is going to condense log base 10 of 2x over x minus 3. Notice I keep that x minus 3 in parentheses because that's a good idea because that's what my teacher taught me to do, and I like my teacher, and I don't want to make him mad. All about that base. 10. We switch. So 10 to the first is equal to 2x over x minus 3. This is over 1. So what I'm going to do is I'm going to grab my fancy dancy blue pen, because I like that, and I'm going to multiply both sides by the GCF, otherwise known as, just going to cross multiply. But these cancel. And I get 10x minus 30 equals 2x. So let me bring that 30 over there, and let me bring that 2x back. So that gives me 8x equals 30, or x is equal to 30 over 8, which is really 15 over 4. My phone's blowing up. I don't know why. Sorry, kids. My physical therapist. My mental therapist. All right. Oh, 14's bonus. Not giving you any hints. Okay. Condense. We're going to condense these. So it's log base 2. It's addition, so we're going to multiply them. X plus 7 times x plus 8 equals 1. All about that base. So 2, and they switch. 2 to the first equals. Now I'm going to double distribute this. X squared plus 15x plus 56. It's a quadratic that needs to be set equal to 0, so I'm going to subtract 2. Subtract 2. Right? I get 0 equals x squared plus 15x plus 54. I need two numbers that multiply to 54 that add up to 15. And hopefully x plus 9 and x plus 6 are my two numbers. So I get x equals negative 9 and x equals negative 6. However, one of those does not work. So I got to get rid of it. So which one's not going to work? Well, let's see. They're both negative. Maybe both of them don't work. But wait a second. Remember, we have a problem when it becomes negative. So if I put a negative 9 in there, won't that be negative? Yep. But how about a negative 6? Would that make it negative? Nope. How about a negative 6 here? Nope. So negative 6 is fine. So don't think you always have to throw out the negatives. Sometimes negatives are okay. All right, we got addition. We're going to condense them. So it's log base 2 of x times x minus 2 equals 3. It's all about that base. So 2 cubed equals x squared minus 2x. This is 8, so I'm going to bring 8 over. 0 is equal to x squared minus 2x minus 8. X minus 4, x plus 2. So my two answers are x equals 4 and x equals negative 2. Go back up here and let's see if either one of those are a problem. Negative 2 right here. Crashola. But 4 would be fine. So my answer is just 4. Done with 16. Oh, we're on the next page. This is exciting. All right, we've got 2 logs, so we have to condense them in by addition. By the way, if you're just sitting here copying me, welcome to Failsville. You will fail, and I will laugh my catootie off. Actually, I won't laugh. I'll cry. I'll be upset. I really will be upset. I really don't like when kids fail. When kids fail, I have to drink more coffee. And I don't like that. So I want you to pass. I want you to be successful, but you are not going to be successful watching the monkey perform, and that would be me. So log base 6, we're going to multiply these two of x plus 4 times x plus 3 equals 1. Now we're going to all about that base. So 6 to the 1 is equal to x squared plus 7x plus 12, right? Because I just double distribute this. Bring the 6 over, I get 0. 0 is equal to x squared plus 7x, and I'm subtracting 6, plus 6. So x plus 1, x plus 6. So I get two answers. X equals -1 and x equals -6. We have to check both. -6 would crash this one. -1 here is okay, and -1 here is okay, but -6 would crash both, so -1 is my solution. Catching. So this one's a problem. I need to condense, because you can only solve these, or you can only change form from logarithmic to exponential, exponential, logarithmic, if you have one log. So I really need to bring this one over. So I end up with log base 8 of x plus 6 plus log base 8 of x plus 4 equals 1. And now it's pretty much the same as the problem to the left there, problem 17. Condense log base 8 of x plus 6, x plus 4 equals 1. And now it's all about that base. Anybody getting tired of hearing that? Yeah, me too. 8 to the 1 is equal to x squared plus 10x plus 24. We'll subtract that 8 by bringing it over, so I get 0 is equal to x squared plus 10x plus 16. 0. X plus 8, x plus 2. So my two answers are x equals -8 and x equals -2. This one will cancel. So -2 is my solution. Let me make sure -2 is okay. Yep, -2 is fine. -8 is a problem. All right. All right, so this one, man, this one looks so difficult. It's crazy. So let's condense the left side. So it's log of x minus 1, x minus 1 over x plus 6. This is bothering me. X minus 1, whatever. X plus 6 is equal to log, why do I keep putting pluses? X minus 6, minus 2, all over x plus 3. Well, now that I have a log equal to a log, this has to equal this. So all I got to do is set those two things equal to each other. Bust out a different pen. Getting tired of blue. So I end up with x minus 1 over, I picked fat one. I don't want a fat one. Over x plus 6 has to equal x minus 2 over x plus 3. Well, I can either cross multiply, or if we can stay consistent from what I've been doing in the past, I'll multiply both sides by the common denominator, which is x plus 6, x plus 3. That's the common denominator. X plus 6, x plus 3. That's the common denominator. Here the x plus 6 is canceled. So what I in fact doing is just multiplying these two together, which is just cross multiplying. So I get x squared plus 2x minus 3 equals, these cancel. So I multiply this together. X squared plus 4x minus 12. I hope you notice the x squareds cancel. So I'll bring the 2x over, subtract 2x, and I get 2x on this side. And I'll add 12, and I get 9 here. Divide both sides by 2, and I get x equals 9 over 2. All right, we're moving on, kids. Who's having fun? Raise your hand. Raise your hand. I am, because I'm spending time with my besties. You guys are my besties. All right, kids, let's go. We're going to condense this. So log of x squared minus 9 all over x plus 3 is equal to 3. Okay. So let's see here. Base 10, all about the base. So 10 cubed is equal to, now I'm going to factor this. I'm going to show you why in a second. X plus 3, x minus 3. X plus 3 here. Look what happens to these. So I end up with x minus 3 equals a g, a big G. So x equals 1003. Ka-ching. Don't believe me? Check it yourself. It works. Moving, guys, moving and grooving. All right, so now we're to the next stage of the problems. I want to get these two bases to be the same. I got a 2 here. I want to make that a 2. So let's go green. So 2 to the x plus 5, x minus 5, equals 2 cubed, because 8 is 2 cubed. Okay, now I just set the exponents equal to each other. X minus 5 equals 3, x equals 8. Don't you wish they were all that easy, kids? All right. 5 to the negative x is equal to 5 squared. Set these equal to each other. Negative x is equal to 2, so x is equal to negative 2. Divide both sides by negative 1. Ka-ching! All right, the next one's not as easy. Because I can't make these into 2's. Like, I'd like to make them into 2's. This I can make the 2 cubed, but I don't know how to make this into a 2. My dog's come down to say hi to me. So I can't do it that way. So now what I'm going to do is I'm going to use change of form. So log, it's all about the base 8, and then these two are going to switch, of 1.2 is equal to negative x. And then I'll divide by negative 1, divide by negative 1, and I'm done. But I got to use my calculator for that because I have no idea what it is. So calculator, ooh, need more space. So control log 1.2, or is it 8? 8 of 1.2. 8, 1.2. Now I don't have to divide by negative 1 because I just know it's negative of that. And let's round it to, let's go 4 decimals. So 0.0876, so x equals negative 0.0, forgot already, 8767. 8767, so 7777. There it is. There it is, done. All right, again, I can't change these so they have the same base. It just doesn't work. So what we'll do is we'll use logs. So log base 2 of 1.5 equals negative x again. So divide by negative 1. So log base 2, control log 2 of 1.5, and it's just a negation of whatever this is, 0.585. So x equals negative 0.5850. If I do the 4 decimal places. 24 down, 16 to go. All right, so the first thing I gotta do is divide by 5, get that 5 over there. So I get 2 to the 3x is equal to 8 over 5. Now, I tried to trick you by making these bases look like they can be changed, but I gave you this crazy 5 out here, and that doesn't work. So I have to go to change of form. So log base 2 of 8 over 5 is equal to 3x. Divide by 3, divide by 3. So now I go back to my calculator, control log base 2 of 8 divided by 5, enter, and then I divide by 3. And I get 0.2260, so x equals 0.2260. I don't know why I did that. 0. That's the beauty of having to write with a pen like this. Gotta love OneNote. Divide by 0.3, divide by 0.3, and for those of you that put that in your calculator and give me 0.666666667, that one serves me right. So 4 to the 0.2x equals, and that's just 2/3. I don't need those decimals. I could put both of them in there, but I don't. Log base 4 of 2/3 is equal to 0.2x divided by 0.2 divided by 0.2. Put this crud in my calculator. Log base 4 of 2 divided by 3, enter, and divide by 0.2. Dividing by 0.2 is the same as multiplying by 5, and I get negative 1.4624. So x equals negative 1.4624. Catching! 26 down, 14 to go. The last page is easy too. All right, here we go. These are fun. I like these ones. Now we're going to change the bases. So I'm going to make this a 2. So that's 2 to the 5th times 3/4 minus x equals 2 to the 4th times 5 minus 3x. So now that I've got them the same, what I'm going to do is set their exponents equal to each other. As long as those two yellow things right there are equal to each other, we're good to go. Oops, I think I got the fat pen again. So I'm going to distribute this. So I get 15 over 4 minus 5x equals 20 minus 12x. Now, I don't like that. That's a bothersome thing. So I'll bust out the blue pen here, and I'll multiply everything through by 4. Now, I'm picking 4 because these will cancel, and then I no longer have that crazy fraction there. So I end up with 15 minus 20x plus 80, equals 80, minus 48x. Get out of there. Sorry, Pooch is going in the wrong place. I'm going to add the 48x over. I get 28x. I'd pick them up, but my back hurts too much. Equals 65. Divide by 28. Divide by 28. And I get, no way that's the right answer. No way. No way, Mr. Krause. No way. No way. 65 over 28? It's supposed to turn out to be like 3 or something. All right, let's check it out. 65 divided by 28. Control var x. Enter. Now let's go look at this problem. 32 raised to the 3/4 minus x. 3/4, 3 divided by 4 minus x. It'll fix it. There it is. That's weird. 16 raised to the 5 minus 3x. 5 minus 3x equals the same weird answer. Gotta love trig. It's not as easy as all the other stuff. We don't like that easy stuff. All right, here we go, kids. So let's get back to a green. So green. 2 to the 4th times x minus 3/4 equals 2 squared times 3x minus 5. Now I just set the exponents equal to each other. So 4x minus 3, because 4 times 3/4 is just 3, is equal to 6x minus 10. Minus 10. All right, bring the 4x over. I get 2x. Bring that 10 over. I get 7. Divide by 2. Divide by 2. X equals 7 over 2. Ka-chang! 28 down and 12 to go. So 2 to the 4th with x equals 2. Ooh, don't forget your parentheses. Squared x plus 1. Now let's set those exponents equal to each other. 4x is equal to 2x plus 2. 2x is equal to 2. And x is equal to, ka-chang, uno. That 30th problem is hard. I need some coffee. I need some coffee from Brugger's. Oh, no, it's not. So this is 3 squared x equals 3 to the x plus 1. Ooh, man, that was tough. Oh, geez. So 2x equals x plus 1. X equals 1. Done. Whew. I'll let you look at it for a second because that was tough. Done with 30. Got 10 left. All right. There are a few that are difficult. This one's not. All right. This is 2 cubed, 3x, or 2x, equals 2 squared times 6. Okay? So this is 6x equals 12, x equals 2. Because 6x right here, 12 equals here, done. This is 2 to the 4th, ooh, in parentheses, 2x plus 3 equals 2 to the 6th times x plus 2. Now 2 to the 6th is 64. 2, 4, 8, 16, 32, 64. So now, set the exponents equal to each other. I get 8x plus 12 equals 6x plus 12. So I get 2x equals 0 or x equals 0. 0 is my answer. So that means 16 cubed is the same as, because I put in a 0 here, that goes away, and I put in a 0 here, as 64 squared. Let me just see that works. That's 2 to the 4th cubed equals 2 to the 6th squared. 12, 12. It works. 0 is my answer. Wow, weird. Didn't expect that. Moving on, kids. Oh my gosh, this is so much fun. Remember how I said 2, 3, or 5? I lied. Got a 6. Sorry. So this is really 6 to the x plus 1. Now this thing here is really 36 to the negative 1. But 36 can be written as 6 squared. So this is really equal to 6 squared times negative 1. So now that the bases are the same, x plus 1 equals negative 2. X plus 1 equals negative 2. X is equal to negative 3. Ka-ching! So 1 over 64 is really 64 to the negative 1. Or I can rewrite it as 8 to the negative 2. So what I have here is 8 to the x plus 2 is equal to 8 to the negative 2 times x. Set these equal to each other. I get x plus 2 is equal to negative 2x. Bring this over here, bring this over there. I get 3x is equal to negative 2, or x is equal to negative 2/3. That was a tough one. So really what you want to make sure you're doing or understanding. Let me show you a different way to do this problem. Another way to do this problem. First, we'll change this to 2 cubed x plus 2. And then this one is equal to, well, first thing you got to do is you're going to have to make it into 64 to the negative 1. And then you got to think 64 is 2 times 2 times 2 times 2 times 2 times 2. So this is really 2 to the negative 6 times x. So what I end up with here is 3x plus 6 equals negative 6x. Add the 6 over, I get 9x equals 6. Divide by x, I get x equals 6 over 9, which is just 2/3. Just another way of getting 2/3. All right, kids, we're almost done. So this is negative 2 to the x is equal to negative 2. Now I got to think about what exponent gives me 128. 2, 4, 8, 16, 32, 64, 128. 2 to the 7th. But it's not 7, it's negative 7 because it makes it in the denominator. Excuse me. So x equals negative 7. Let's check. I feel like that's not right. I don't know why. I feel like I did something stupid. So negative 2 to the x, so parentheses, negative 2, parentheses, raised to the x equals negative 1 over 128. Negative 1 over 128. Oh my God, it's so nice. So negative 2 to the x is equal to negative 2 to the 8. But not 8, but negative 8 because it's a fraction. So x equals negative 8. Just set the exponents equal to each other. Ka-ching. We got 3 left, 4 left, 4 left. So this is 3 to the x is equal to, now isn't this really 3 squared? But it's in the bottom, so it's really 3 to the negative 2. Set the exponents equal to each other. I get x equals negative 2. Ka-ching. This is really 5 cubed. But since it's in the denominator, this is really equal to 5 to the negative 3. So what I have here is 5 to the x is equal to 5 to the negative 3. And therefore, x is equal to negative 3. That's probably right behind my head. So there it is. 2 left, kids. And then I'm done. Woo! All right, we got a little bit of work to do on this one. So I'm going to change this to 2 squared times 2x plus 1. is equal to 2 cubed times 2x. Set the exponents equal to each other. I get 4x plus 2 equals 6x. 2x equals 2 or x equals 1. 3 squared, 3x plus 1, equals 3 cubed x plus 2. Set the exponents equal to each other. 6x plus 2 equals 3x plus 6. All right, bring that over. I get 3x equals 4 or x equals 4 over 3. Oh my God, that was so much fun. I had a good time. How about you guys? Did you guys have a good time? Oh my God, I hope so. Anyway, thanks for coming. Thanks for joining me, and I will catch you on the flip side.